Okay, this video tutorial looks at the mathematical strand of patterns in algebra, and more specifically we're going to focus our understanding on further expansion. Okay, so basically further expansion builds on what we've been looking at with basic binomial expansion, or using FOIL, the method FOIL to expand to find quadratics. We've also probably looked at the perfect square or difference of two squares, but now we're going to look at I guess complicated expressions that enable us to use repeated use of expansion laws in order to remove the brackets. So as an example here, basically we've got a bracket with two terms in it and a bracket with three terms. And what we need to do is we need to multiply every term in the first bracket, so the x and the 3, by every term in the second bracket. So we're going to expand them out and then collect some like terms here. So this becomes 2x cubed, take 5x squared, plus 2x. And we've got plus 6x squared here, take 15x plus 6. Now I can collect some like terms here. I've got a negative 5x squared and a positive 6x squared there. I've also got a 2x and a negative 15x. So when I collect the like terms, I end up with 2x to the power of 3 plus x squared, take 13x plus 6. And we can do that as well with our second example here. I'm going to use FOIL for my first two brackets. So that gives me 5x squared plus 2x plus 15x plus 6. And that still gives me x take 4, but now I can collect some like terms here. And I end up with 5x squared plus 17x plus 6 with x take 4, and now I'm in a similar situation to what I was above, where I'm now going to multiply my first term in my first bracket by both terms of my second. That's going to give me 5x cubed, take 20x squared, then I'm going to go 17x multiplied by x, and then 17x multiplied by negative 4, which would give me plus 17x squared, take away 68x, and then I'll use a different color here. I'm going to times by the 6 and the minus 4, so I'm multiplying each term in one bracket by each term in the other, plus 6x, take 24. I can then collect some like terms here. I've got some squareds, and I've also got some x's to the power of 1 here. So my overall answer for this would be 5x cubed, take 3x squared, take 62x, take 24. I'm just going to go through some example questions here about expanding when we're looking at a power that's greater than 2. Okay, so we've been looking at perfect square and the difference of two squares, binomial expansion, but only with a power of 2. So we're going to look at the power of 3 now. So again, x plus 3, x plus 3, x plus 3, expanding them out. I can see the first two make the perfect square, so I know straight away this is x squared plus 6x plus 9, and x plus 3. I can now use the further expansion method that we just talked about, where I multiply my x squared by the x and the 3. So that gives me x cubed plus 3x squared. I'll make that squared a little bit more obvious. Then I've got 6 by the x and 6 by the 3, which gives me 6x squared plus 18x. And then I've got the 9 that I can multiply by the x, 9x, and 27. And I can now collect my like terms, and I end up with x to the power of 3 plus 9x squared plus 27x plus 27. And let's look at our second example here. Again, we've got 4x take 1, 4x take 1, 4x take 1, and 4x take 1. I can look at these and I can go, well, perfect square and perfect square. So I'm going to multiply them out. I end up with 16x squared take 8x plus 1, and that's on both of them. And now I can simply multiply each term in each bracket and then collect like terms. So 16x squared times 16x squared is going to be 256x squared. Alright, so that was that. Then I've got 16 times negative 8x, so that becomes negative, whoops, I'll use a different colour, negative 128x cubed, so that was that one there. And then I've got 16x squared times 1, which is just 16x squared. So I can do the same. I'll use a different colour here. I've got to go negative 8x times 16x squared. Well, we already know what that is. So that's minus 128x to the power of 3. Then I've got negative 8x times negative 8x, which is positive 64x squared. And then I've got, so I've just done that one there. Then I've got negative 8x times 1, which is negative 8x. And now I've got my last, so I've got to go 1 times 16x squared, which is 16x squared, 1 times negative 8x, negative 8x, and 1 times 1, which is 1. Now I can collect some like terms. Oops, this is actually meant to be to the power of 4. Hopefully somebody picked that up while they were watching. So we end up with 256x to the power of 4 here. Then we've got here and here some like terms. So minus 256x to the power of 3. We've got x squared, and x squared, which will give me 96x squared. Then we've got negative 8x, gives me negative 16x, and then I'm left with plus 1. Okay, so here are some practice questions I'd like you to have a go at. Feel free to pause the video. When you think you've got the correct answer, continue the video and see how you went. Okay, so let's see how you went. In our first question, we had x take 2, x take 2, x take 2, and I know my first two brackets make the perfect square. This becomes x squared take 4x plus 4, all outside of x take 2. Alright, and then I can multiply out, gives me x cubed take 2x squared take 4x squared plus 8x plus 4x take 8. Collect the like terms, x cubed take 6x squared plus 12x take 8. In our second example, we've got 2x plus 1, 2x plus 1, 2x plus 1, and 2x plus 1. And I know that's the perfect square for the first two brackets, and the second two brackets will do the perfect square as well, so we can expand that out, and we end up with 4x squared plus 4x plus 1, and again 4x squared plus 4x plus 1. And now I can multiply them out. So 4 times 4 is 16, so that's 16x to the power of 4 plus 16x to the power of 3 plus 4x squared plus 16x to the power of 3 plus 16x squared plus 4x plus 4x squared plus 4x plus 1. Now I can collect some like terms. I've got power of 3, power of 3. So that gives me 32x to the power of 3. Then I've got x squared, x squared, x squared, which gives me 24x squared. Then I'll use a different colour here, x and x plus 8x, and I'm left with plus 1.